Everybody's been sitting for too long. Okay. So we developed a new smartwatch system called PebFit, and our main goal was to combat what's been going on here. We've been sitting around doing nothing, and so I just did what our system does. I told you, hey, you've been sitting around too long. Get up and move. So we're going to show you a quick little video.
PebFit is a smartwatch-based fitness app designed to improve the quality of life for those who remain sedentary throughout the day. The system consists of a Pebble smartwatch and an Android smartphone, both running the PebFit software. Using the Pebble smartwatch's onboard accelerometer, we monitor users throughout the day and determine when they've been sedentary for too long. After a long period of sedentary activity, such as sitting on the couch for too long, PebFit buzzes the smartwatch and reminds the user to exercise. This is where most systems currently on the market stop. They rely on self-reporting and self-motivation. It is up to the user to be active. PebFit takes this approach several steps further. After the user has been sedentary for too long, the exercise reminder provides a suggested exercise for the user to perform. Should the user choose to accept this exercise, the accelerometer data will be collected during the exercising period. After the exercising period is complete, PebFit calculates the number of repetitions that were completed and determines whether or not the user performed exercises correctly. This increases user accountability and prevents them from gaming the system. PebFit is motivated by societal trends towards sedentary lifestyles, contributed to in part by evolving technology. This trend towards inactive lifestyles has negatively affected both personal and public health. We believe that technology should improve life in all aspects, not only by making tasks easier and faster, but also by promoting wellness. Technology should complement active lifestyles, not detract from them. By integrating emerging mobile technologies and computing techniques, PebFit takes an active role in promoting general well-being.
Okay, so howdy. As mentioned, we are a Pebble smartwatch. This is the Pebble Watch-based fitness application. What happens is wearing this watch, we continually monitor the user throughout the day, deciding when they've been sedentary for too long. After they've been sedentary for a while, we prompt the user to get up and exercise. Now, as stated in the video, this is where most things currently on the market stop. These devices are Fitbit and Jawbone. Throughout the day, they'll give you regular reminders kind of on a schedule, every 30 minutes, 45 minutes or so, it does tell you to do something, which is great unless you have no idea what to do or don't really want to do it.
So a little bit about motivation. As you all know, we're starting to face that obesity epidemic. We're all becoming very sedentary. We all have computers that we work at all day, especially computer science majors. And so a little personal. My dad is very overweight, and part of the reason is that he's too sedentary. He'll just come home and sit all day. And so my idea was I wanted to do something health related, and Chris and Ari also wanted to do something health related with wearable computing. So that was kind of our motivation behind creating this system.
So we did some research on the already existing systems, as my classmates were explaining. For example, we have Fitbit. It's very popular, it's been on the market for a while, and it is web-based. It's also a good activity measurement instrument. The problem with this is the limitations it has. For example, sometimes it will confuse the periods of sleep. It's widely used to measure the quality of your sleep with actual wake time. And it's not really aimed for detecting if you've been sedentary or exercising, increasing the fitness part. On the other hand, we have something which is just an app from the smartphone, specifically for Android. The Edamona Sports Tracker is one of the highest rated Android apps of this kind, and it's pretty sophisticated, pretty much using an odometer for activities such as running, cycling, walking. But all of this, for example, is distance-based. You would actually need to either own a bike or actually go out and walk how this compares to what we're doing with PebFit, as you could see in the video, the user does not need any sort of equipment or even that much space. So this is also aimed for people who are working in a cubicle or an office for extended periods of time, and they just need to get a little bit more active instead of sitting all day. They'll have a reminder, and they will be able to perform all of their exercises in a confined space and without any equipment.
Okay, so we had our task in mind. We need to do several proof of concepts to make sure that we can actually produce this. We need to look at information we can collect about specific exercise to make sure we can differentiate between different exercises, as well as being able to differentiate between a sedentary period and an active period. This graph right here shows 3 axes on the triaxial accelerometer on the Pebble smartwatch of 4 repetitions of the toe touch exercise. We can see spikes in the data, and using data analysis, we can count the number of repetitions here. So we found that several exercises are distinct by looking at the axis activity. We built numerous demonstrators on the Android to capture and analyze data from both the accelerometer on the Pebble and from the Android, and do data pre-processing. Next. Okay, so we developed a Pebble application that runs on the Pebble smartwatch. It's written in Objective-C, a very compact program that takes X, Y, and Z values from the accelerometer that show instantaneous acceleration in 3 directions. We take this data and send it to the phone. Also, the Pebble smartwatch app listens for messages coming from the phone and displays messages like the prompt exercise. From the buttons on Pebble, you can accept or decline prompts to exercise. So our main component is checking for sedentary. This occurs most of the time during the day. When you're sitting at your desk, we'll have a continuous streaming of data from the Pebble smartwatch to the Android phone. And here's an example of sedentary data versus active data. As you can see, in sedentary, there's very little activity on any of the axes. There's very little change from time to time, from time point to time point. So we continuously log these acceleration values during the sedentary checking period. If the sedentary threshold has not been met, i.e. the user has not moved enough, has not provided enough acceleration from time to time, over an extended period of time, we determine they've been sedentary. And that is when we prompt them. The next component is after we prompt the user to exercise, we need to count the number of repetitions of an exercise they perform. This is part of the user verification system that actually determines whether or not they did the exercises they were asked to do. So to do this, we take the data from the 3 axes on the accelerometer and compute a sum of squares. After computing the sum of squares, we compute an exponentially weighted moving average. So we have a semi-straight line plotted down the middle of the sum of squares plot. That is the red line right here, versus the accelerometer data, which is the blue plot. To count the number of repetitions, we count the number of times that the exponentially weighted moving average plot crosses the sum of squares plot, and scale that number back based on the waveform of 1 to 5 exercises that we have.
Okay, so I kind of took what Chris did with all those fancy algorithms of analyzing the accelerometer data, and I put it all together into the Android app that is kind of the, you can think of it as like the hub of information. It's getting all the accelerometer data from the watch. Then we have the PebFit will, or the Pebble watch will send the accelerometer data to the phone, and a service is running, doing the analysis of checking for sedentary, like Chris mentioned. And then once they've reached the sedentary threshold, we alert them to a exercise, and I'll get to that next. So the exercise plan, we based it off of, actually Chris did some crazy research and found the Canadian Air Force during the 50s had a problem with their men that they were getting out of shape. So they developed this plan to slowly, incrementally increase the fitness of their Air Force. So we kind of use this as a basis for our program, just because they're simple exercises. These are the 5 ones, and they get increasingly hard as you go through the program. But there's something like, elderly people or people that don't really exercise, they can pick them up quickly. They're always the same, just more difficult and more difficult. On the back end, to hold all this data, hold user data, their progress to the system, and then also to hold exercise information, we use a SQLite database locally on the phone, just because we felt that with health-related things, most people are kind of private about that, and we decided the whole server, holding people's data was just something we didn't want to get into at this early stage. So this is kind of the tables in our database. Okay, so kind of like we've already mentioned a few times, we've got a service running that is collecting the data, checking to see if they're sedentary. If the sedentary flag goes to true, it alerts them on the watch, gives them the exercise on the watch. They can accept or decline it. So you think of decline as a snooze kind of thing. Sometimes if you're in a meeting, you can't get up and exercise or something like that. But so when you click accept, it takes you to this screen, shows you it pulls from the database your next exercise, shows you the exercise. You click start. It starts another service that is doing similar things to the sedentary as a sedentary service, but it's collecting these XYZ values, storing them to a file for a later classification that later we'll be talking about. But it also, at the end of it, will do some of the algorithms he was talking about and count the reps and tell you whether you did 12 reps or not. And then whether or not you've done it correctly, we felt it was really important we need to give the user feedback. So awesome, you did it. You did an awesome job, or no, you didn't do the right amount. But we also tell them these are how many reps you actually did, so they can have an idea of, oh, maybe I need to do a better job next time of really getting into the exercise to log the number of reps that we want them to do. So
the system is very individual. It's just for the smartwatch and the Android phone of the user, and as he mentioned, we're only handling that specific user. On the computer end, you have an extra application that will actually do classification of your exercises. As you can see in the data, the exercises visually look different when you graph them. So this numerical data actually shows you the differences between them, and we do classify them with a statistical analysis to give even further feedback to the user. As you can see, it's a very simple interface. Once the phone is connected, they will just have to press the go button, and it'll show you if you performed correctly or not, telling you pretty much where you're standing on your performance. So in order to do this activity recognition, I use something called WECA, and it is a collection of machine learning algorithms for data mining tasks. And it is open source under the GNU General Public License. So anything developed with WECA, if it's published, must be provided with all the source code. What I used from WECA was the actual interface first to test all the data that we collected just at the very beginning from the accelerometer to find what features were actually necessary for classifying the exercises. Out of the several, I calculated different things on an Excel worksheet, such as the average for the X values, the average for the Y values, the minimum, the maximum, the distance between the lowest point and the highest point. And running several tests, I determined which ones were actually useful in determining the exercises. So implementing it into a small Java application, I used WECA, which uses specific naive-based classification. So a naive-based classifier is simple statistical probabilistic classifier that implements Bayes' theorem, pretty much having a naive assumption of the different features. What this means is it just assumes that all the features that you're given are independent of each other, so they shouldn't modify what the object is. It's the collection of features will tell you if all these criteria are met, it's most likely this object. Then for our first user study, it was mostly a pilot study. So we wanted to see more of the behavioral aspect on users regarding fitness and applications. So the first one was without any technology whatsoever. We provided the users with a worksheet with the 5 basic exercises that they've been talking about. A picture was provided, title, number of repetitions, and a short description of what the steps are. With this, we wanted to assess how fitness apps were used. So with the questionnaire at the beginning, users told us, no, I don't use any apps, or what I think about them. And we actually found out that a lot of people really are not interested in fitness apps. They seem too complicated, or they just don't get motivated enough to keep using them. They might be new at the beginning and then they become boring. And we also assessed how well they performed without technology and how they felt behaviorally about this. So with the results, we found that less than 50% of our users actually did not use any fitness applications. And of those who actually have tried them, did not find them useful at all. And whenever we asked them, well, what would you be looking at if you wanted to try a fitness application, they reported similar things to what we were actually planning on building. Such as, well, I'd like to be suggested as like something that would keep track of everything for me, so I can actually like have fun with a friend and talk while I'm exercising if I want to. Nevertheless, most people say they weren't sure if they would actually find this motivating. So on user study number 2, we had 2 groups. Ones were new people coming to try the system. They had never seen the workouts before. And some returning people that had tried the plain workout. And as we saw in the first user study, people were actually bored with just a plain workout, and they would not really be motivated to keep working out on their own, even if they had the information available. So on user study number 2, we wanted to assess how well our system performed and how well the users responded to the system pretty much. So we got surprisingly good results actually. The vast majority of both the returning and the new ones said that they really liked how the system kept track of the repetitions, and they found it very useful. And overall, considering usability, ease of use, over 70% found the overall system, including watch and app, useful. So most reported that the system, PebFit, was preferable than no system at all. They actually seemed to have fun. And 80% of them claimed that they would be motivated to keep going since they saw that they would have increasing difficulty in the exercises as they went on. Also, what I noticed with the user studies was even though we provided the exact same images and the exact same description, people seemed to understand it a little bit better with the app. I don't know if they felt more dynamic about it, but they responded quicker to doing the exercises. In a normal workout, they would read the instructions for several minutes, and they try to perform it, and we also noticed that people did exercises differently, so their interpretation was different. Whereas in the second user study with the system, we noticed people were quicker to get through the workout. They would be sitting reading for sedentary time, and as soon as they were prompted, they would accept, perform the exercise, click on their app that they were done, and go back to chilling and talking to us while they were waiting for the next prompt. So I noticed that behaviorally, the group with the system performed a lot better fitness related. So finally, in conclusion, our system PebFit is actively monitors the users and determines the long periods of inactivity. This is, as we've said, very useful. We read several health-related papers in which they talk how small increases in exercise a day would actually have great health benefits in the long run. Being completely sedentary or having at least like 11 minutes a day of exercise and activity would be plenty for, after the years of doing it, actually seeing the health benefits of this.
So just quickly, I was going to go over, since we weren't told we were supposed to provide lessons learned, but quickly, I was just wanting us all to kind of talk about what we learned, something that I ever wanted to know. Specifically, I didn't emphasize that, but all these services I'm talking about are running in the background. And sometimes you can have issues with, I think another group talked about it, about Android wanting to shut those services down after a while, if, like for battery purposes and things like that. So just combating that, and we really got to use almost everything we've learned in computer science. We did some database work, we did UI, we did analysis, we did, all these different things we've been taught. So I feel like it was very beneficial as a learning experience.
So from a more several areas perspective, it is a computer science project, but we did approach from a health perspective. So you have several fields of study there, and as well all the mathematical background of this application, and all the statistical analysis that the data is dependent on for actually providing feedback to the user. It's another thing important to our learning. So that's something I wanted to add as well.
I think we'd like to open the floor for questions.
So obviously you're streaming data from a tablet to Android smartphone and you have batteries. So how much did that actually impact the battery?
Over the time that we were doing it, which was an hour or two at a time, we didn't notice major battery issues. However, the advertised battery life for a couple is 5 to 7 days. After heavy testing, we sometimes have to recharge the couple after 2 to 3 days. So in some cases, in our lightweight use case, we experienced that reduced battery life by about 50%. Future versions, we'd like to improve that battery life. Part of it is Pebble is not in itself multi-threaded, and the application has to be running in the foreground to be sending data to the Android unit. So
That was a lesson learned. We learned a lot about wearable computing right now is not where we thought it was when we started, at least with the Pebble. We were thinking, the Pebble can store lots of data and do lots of these crazy things, but really it's wearable computing, at least in the Pebble's case, still very limited. So it's just, adapting to that. Like, we had to keep going. We learned this, but we had to keep going.
We actually turned that into an advantage. When one of this exposition, the engineering showcase, we were discussing with other people about the different watches that are out there in the market, and this person was telling us about this one that did so many things, but the battery life was very short due to all the things that it approached. On the other hand, our use of Pebble, since it's so simplistic, it doesn't really store anything, we are actually able to keep our app running longer because we're not that concerned about the battery failing.
any other questions?
All right, if there's no questions.